Our topic for today is sampling and sampling distributions. After completing this section, we should be able to understand what simple random sample is. So a simple random sample is simply a subset of a larger population that is chosen in a way that each member of the population has an equal chance of being selected. So this topic is fundamental in statistics because the individuals or items are usually selected randomly without any bias. By so doing, you ensure that every sample is representative of the entire population. So the importance of simple random sampling is that it is crucial in statistics when we're analyzing samples because it helps us make valid inferences about an entire population. I hope we're together. And so simple random sampling is very important because the sample that is actually derived from the entire population is not a skewed sample, which is in favor of a specific subgroup or characteristic. It makes generalized results. We will also be able to look at what descriptive and inferential statistics is. So when we're dealing with descriptive statistics, we will look at representations and organizations of data, which will be used to describe the main features of the data set. For instance, the mean, the median, the mode, the standard deviation, which we're looking at in the first few topics, but now we're going to summarize and simplify the data for better understanding. Inferential statistics, on the other hand, will help us use the data from a sample to make inferences that will draw conclusions about a larger population. Among others, inferential statistics will help us generalize the findings that we're going to find from an entire population. We'll also look at sampling distribution, which is a theoretical distribution of a statistic, like the mean, the proportion, the variances. These ones will be calculated from multiple random variables of the same size. From a population, it shows how the statistic of interest varies across different samples by providing insights into the variability of a statistic. We'll look at the mean and standard deviation of a sampling distribution, where the mean of the sampling distribution will be equal to the population mean. We'll also look at what is called the central limit theorem. This one helps, or it states that regardless of the population distribution, the sampling distribution of a sample mean usually approaches a normal distribution as the size increases. So it provides a sample size that is significantly large. So let's go to discussing ingredients of a sample. What is a sample? A sample is simply a small portion of a big population. So if we're dealing with an entire population here, if we're going to pick a small representation of this is a sample. All these units are called a population. And this, carrying these samples for the sampling frame. Now, sampling is very important in statistics because it helps us understand the nature of deriving elements. So there are several types of sampling that are there, and we need to understand each of them, stating the advantages and disadvantages. So sampling is crucial because it helps us gather data from a subset of a larger population when it's actually practical to collect the entire population data. So we have several types of sampling which emanate from the following. We have generally two types of sampling. We have what we call probability and non-probability sampling. So each of these ones have their own characteristics. So non-probability sampling, what we call the simple random sampling. This is a method where every member of the population has an equal chance of being selected. In this sampling method, we are using a random number generator to draw names, hearts, and numbers that will help us calculate the samples. So we also have what is called a systematic sampling. In this systematic sampling, you select every nth item from the population list, and you start selecting the kth element. For instance, you would have an opportunity to pick every 10th of the population. That is called systematic. And systematic sampling is one we use when we're taking every 10th that we have. We also have what is called stratified sampling. It's a method where the population is divided into subgroups called strata that have certain similar characteristics like age from 10 to 12, from 12 to 15, from 15 to 20 have similar characteristics, and you pick from each stratum a member to represent the entire population such that every group is represented. So you can also pick from middle management, top management. These are very important. So we also have other sampling techniques like cluster sampling. This is a type of technique that is used when we, instead of selecting sampling from individual elements, a cluster sampling involves dividing the entire population into clusters or groups. Then you randomly select some of these clusters where all the members in that particular cluster are included. For instance, Southern Province, Northern Province, all the 10 provinces we have, then you shall randomly select each of those provinces. So we go now to non-probability sampling methods. We have convenience sampling, which is a non-probability sampling method where researchers will select individuals who are already available and accessible based on convenience. This is very important because it is used for a cost-effective kind of sampling. Other sampling methods that we may be keen to understanding in non-probability sampling would be what we call the purposive sampling method. This is also called judgmental sampling, where researchers will intentionally select specific members or elements from the population based on their expertise and judgment. You need to agree with me that not everyone who's intelligent can teach. So purposively, you choose people who are vocal and have a passion to teach. And this is what we call purposive. You purposively choose. You want to survey the effect of COVID on a breathing long term. You purposively sample those that have only experienced COVID because to them, it will make sense. We also have quota sampling, which is similar to stratified, but is in non-random, where researchers select participants that are randomly selected to ensure that a certain number of percentage from subgroups are included in the sample. We also have snowball, which is a sampling technique usually used when we are creating a social network, relying on hard-to-find populations, where we start with a small number, ask them who knows who until we reach the number that is desired. It is an investigative kind of sampling. So with these sampling methods, we now go to the formula that we use in sampling. We have two main formulas that we use for sample size: Z squared S squared over A squared. We can also use Z squared PQ over what? E squared. So these sampling methods are used when you know what your Z is. So I taught you how to understand our song using the Z. So we have 99, 98, 95, 90. The difference from 100 is called the significance level. So we have 1, 2, 5, and 10. Then this is 0.01. This is 0. What? 02. This is 0.what? 05. And this is 0.what? 10. 2.58. 2.33. 1.96. And 1.64. So these are figures that you need to understand. So under sampling, we also have estimation formulas where we use the sample confidence interval is equal to the mean plus or minus Z, standard deviation over square root of n. We can also use a confidence interval with the proportions as well. So we have the proportion plus or minus Z PQ over what? Capital N. So confidence interval is simply a range. For instance, we have 10 to 20. This is the range where this is called our lower bound and this is called our upper bound. The mean is simply the average of the two. When you add the lower bound, you divide by 2. So here we're going to have what? 10 plus 20 divided by 2. So here we're going to have our mean to be 30 over 2, which we get 15. So this is how we calculate our mean. Error in this case will simply be the difference between the upper bound and the lower bound divided by 2. So we have 20 minus 10 over 2. So this is 10 over 2, which is plus minus 5. So sometimes you'll be asked to say you have a confidence interval of between 15 and 45. And your sample size, you're being asked to calculate when you have, let me say you're given a sample size of 100. You're asked to find the mean error the standard deviation. Okay. And 95% confidence interval. So already the mean is simply the difference between the lower bound, the upper bound, divided by 2. So 45 minus 15 is 30. 30 divided by 2, we get our 15 as our mean. Then we also have the error. And this is the error, the difference. We also have the mean. The mean is simply the lower bound plus the upper bound divided by 2. So 45 plus 15 divided by 2. And we get 60. 60 when divided by 2, you get a 30. So that's how we find our mean. Then we know the sample size formula is simply given by z squared, s squared over e squared. So our z at 95% is what? 1.96. Our standard deviation, we don't know. That's what we're looking for. Our error is 15. Then our n is given as 100. So we cross multiply. So this times that, we have 1.96 squared times the variance is equal to 15 squared times 100. So in this case, we'll divide by 1.96 squared both sides, 1.96 squared. So in this case, we're going to find our variance. Are we together so far? Are we together so far?
Yes, we are.
So what we're getting here is our variance. So what do we get when you can compute that? There's a calculator nearby. Do you have a calculator nearby? Please help me. Right, so the answer we're getting is actually the variance and not the standard deviation divided by 1.96 squared. Where is 1.96 coming from? No. Where's 1.96 coming from?
It's the Z.
Correct, the Z.
Collins, how we find the standard deviation here is still the same way. You square root the variance.
The normal way with square root, yes.
Okay.
So now in terms of confidence interval, suppose you have a mean of 10, confidence level of 95%, standard deviation of 36, and n is standard deviation of 12, and n is 36. Find 95% confidence interval. So 95%, we know that our Z is what? 1.96. So the Z, we know that mean plus minus Z, standard deviation over square root of n. So our Z is 1.96. And our standard deviation is 12. Our n is what? 36. So square root of 36 is 6. 6 into 12 is 2. So 1.96 you multiply by 2. You get what? 3.92. So when you subtract there, we get 6.08. When you add there, we get 13.92. So this is how we do the confidence interval.
Sorry, maybe I didn't really understand how you came up with the... No, there I did understand. But then after the 3.92, which was a multiplication of 1.96.
10 minus 3.12 is 6.08. 10 plus 3.92 is 13.92.
Oh, okay. Okay, thank you.
Sometimes we'll be given a proportion, 20%. Our n is maybe 50, and our alpha is 0.02. So we need to understand our sum. Our 0.02, what is our Z? 2.33. What's the confidence interval for proportions? P plus minus Z PQ over N, capital N. So we know that if P is 20%, which is 0.2, Q is 0.8, they should add up to 1. So here it's 0.2 plus minus 2.33. Then here we put 0.2 times 0.8 over N. N is what? 50. So 0.2 times 0.8 divided by 50, square root of answer, times 2.33. So this is about 0.13. This is as good as 20% plus minus 13%. So here we have 7%, 23%. All together?
Yes, we have. So does it matter whether you start with the plus or do you always have to start with the minus?
You always start with the subtraction.
Okay.
Systematically. logically. So I want you to be perfect. Don't start with a bigger one. The lower bound should always start. I'm really worried about the song because this song is what will keep you. So let's go through the song again. Can you fill it up for me? So continue filling for me.
That should be 2, then 5, and 10. 0.02, 0.05, 0.10. And I have no clue how the Z is found.
This is the most important thing. Please tell me.
I'll pay attention.
Who wants to try? Wants to try? Okay. Let me help you understand why I want you to memorize it. Because the procedure is a little bit long. So I figured out that it'd be easy for you to understand, just memorized. So how do we get the 95%? You just do 1 minus alpha over 2. You get the answer and read it from inside the table. So what is the alpha for 95%? 0.05. So 1 minus 0.05 over 2. We get 0.9750. Then let's look for this one inside the table. 0.7950. Where does it take you? It is somewhere here. I taught you how to read from inside the table, so here it is. So this is 1.9 and 0.06. So this gives us 1.96. So this is where the 1.96 is coming from. So tell me, for 98%, who wants to try what we do? One minus what? 0.02
0.02
over 2.
over 2.
Which is 0.9900. So let's look for this one inside the table. The closest is this one here. 9900. So what is the reading there?
2.33.
2.33. 90%, what do we do? 1 minus 0.10 divided by 2. This will give you 0.9500. So let's look for 0.9500. You go in here, 0.9500 is equidistant to these two. This one is below by 5 points. This one is above by 5 points. So we pick the in between. So the exact one is 1.645 because 0.005 there, packet. If it was here, it would have said 1.655. If it was between 6 and 7, 1.665. So it's in between here. No wonder the most accurate here will say this is 1.645. Some books will accept 1.64. Some books will accept 1.65, depending on your lecturer. But the exact one is 1.645. Similarly, even this one for 99%, 1 minus 0.01 divided by 2. What do we get? So 1.01 divided by 2, then 1 minus answer. We're going to get 0.9950. 9950. So what we're going to find here is between the 50 is between these two. This is 49 and this is 51. So 50 is equidistant. So what is the exact figure here? 2.575. That is the exact figure. 2.575. So some books will usually get 2.58. Others will get 2.59. But the precise one is this one. So usually you find these ones that are being used. At least you know where they're coming from now. No wonder, without anything, I teach you the song. 99 is what? 2.58. 98 is what? 2.33. 95 is what? 1.96. And 90 is what? 1.64. You need to master this song. Are we together? So the top two are 2.2 something. The bottom two are 1 point something. If you're not given, the standard is 95%. All right, so let's go to the tutorial sheet. Here's the question we're given here. Okay. We try to answer this one. Let me it on our clipboard. So once you try to answer, we can start with the first part to find sampling error and the types of sampling and give examples of each. So what is sampling error? No. Okay, and examples of them, we're just for mentioning them. So sampling error is simply what? So sampling error is simply the difference between the sample statistic population parameter. For instance, you get 10 balls in a data set. That's a population. Then out of that, you only manage to weigh 5 balls and you get the average to be 1.2. And the actual weight for the 10 balls is 1.5. The difference between 1.5 and 1.2 is called the sample error. So the difference between the actual of everything and this population sample for the 5 balls, the one you sample, that's what sampling error. Types of sampling with examples. So we talked about simple random sampling. You can randomly select 100 students from CBU or UNILAS to represent the MBA class. Stratified sampling, dividing the city into populations of income levels, low, high, mid, then you pick 50 from each of these levels. That's stratified. Cluster sampling, you pick 10 out of the 10 provinces in Zambia, you pick maybe 7 provinces. Systematic, you go to check who has HIV, you pick every 10th patient in a bed. That is what? Systematic sampling. All right. Are we following?
Yes, we are.
Then we go to the next question, which is now asking us to calculate the 90% confidence interval with a sample size of 40 and 90% confidence interval for a sample mean, given that we have 5 orders. So what are we given in here? I've been given our Z. What is our Z? Z at 90 is what? 1.64. Z at We only have one Z, 90, 90. Okay. Then the other thing we've been given is what? The mean. The mean is 40. Okay. What else are we given? Our standard deviation. We should start it from here. So question is as follows. A random sample has an average of what? 70. So we have an average of what? 78.25. Standard deviation is what? 22.50. But A, find a 90% confidence interval. Given our sample size N is 40. What you need to understand is that the bigger the sample size, the more accurate your interval will be constricted. For instance, 2 to 8, 2 to 4. The most accurate one of the two is one with the constricted time interval, because somebody says, what time am I going to come? I'll come between 15 and 18. And somebody says between 14 and 15, you'd be comfortable with the one who gives you a smaller range. So if your sample size is greater, you have a constricted range. If your sample size is small, constricted, you have a wider range. So here our mean is what? 78.25. And our Z at 90% is 1.64. Our standard deviation is 22.50. And our N is 40. The same question has been brought with the same parameters at 75. So what they're just asking you is to derive the difference that comes as you increase the sample size. So what you need to understand is that the bigger the sample size, the more accurate and constricted the interval. Are we together? So we understand that a smaller sample size has a larger standard error. So meaning there's a wider confidence interval. And the bigger sample size has a narrower. So these two things will distinguish your sample size. So this is the explanation they want you to understand. Let me beam it here for you. The difference, the confidence interval is in two things. Number one, a smaller sample size has a larger standard error. So this will lead to a wider confidence interval. But a larger sample size has a smaller standard error. So meaning you have a narrower confidence interval. Okay. Then we go to the other. What's the difference between a point estimate and the confidence interval? In what role do they play? In what? What role do they play? So anyone from your own local understanding, what's the difference between the confidence interval and the point? So as the term denotes, a point interval, just like the mean and the average, is simply a single value that is used to estimate a population parameter. It represents the best guess that you could have. A confidence interval is constructed around a range within which you would want to be sure. So what is the role of confidence interval? It represents a degree of confidence or assurance that we can give the level of accuracy. People from the village are very bad at approximating. When they're telling you the distance, they'll say, Paul, but it's a very long distance. Now, this confidence level is one thing that really we desire to question integrity that we have of our doctors and our engineers. If they say, if this patient is going to take this medicine, I'm 99% confident that they'll be healed. So we rely on somebody's expertise. So the role they play is they give assurance of the accuracy in their precision. And then 5% confidence interval means that if we're to take samples, the confidence that we have in each sample is expected to be true within a certain parameter. The higher the confidence level, the wider, the higher the confidence we have in their results. So construction of confidence interval is given by the mean plus Z, the standard error. So in this question here, constructing the 5% confidence interval of the age, that will be your homework. We have a sample size that's 6, average 4 to 1.7, and we're given a standard deviation of 6.9 years, and constructing 95% and 99% confidence interval, and give a distinction between the two. So I have covered this entire topic in 30 minutes in the best possible way. So I'll need you to do this homework. I require of it tomorrow. And any questions, yes, sir?
Yeah, I was just thinking from your explanation. So could it be, that's the same principle that they borrowed in terms of determining interest rates over a period of time, eh? Where they give a range for Lusaka Stock Exchange and these other treasury bills.
Exactly. So that has two elements. There's what we call trend analysis that is used from past consumer behavior, as well as that factor. Yeah.
Okay, it makes sense now.
Yes.
All right. Thanks so much.
So I would love so much that you actualize these things that your school may not take time to really appreciate. When I hear such questions, I know, and I'm happy that people are now relating them to real life situations. All right. So for me, I have bitter issues with doctors. So if we have any here, especially within our Zambian confines, because the levels of precision in the, you're in the hands of a professional. And sometimes there's much to be desired in the prescriptions that they give, misdiagnosis on simple matters that could easily need to be done within their profession. So there's what we call vicarious liability that the Westerners have actually embraced where it comes to the law, that a doctor can be personally sued for a negligence that has been committed on a life that has been lost, where they should have worked within certain confidence level. So because of lack of these applications, we get to lose lives carelessly because of the misappropriation of this topic. It's a very wide and big topic that needs desires to be really explored, whether you are a doctor, a pilot. Imagine having to employ a pilot who is 60% confident of what they're doing. The confidence level is low, and they're now getting lives on board. So these are things that really you should look at it from a bigger perspective. So I've sent you your homework on the groups. I expect you to attempt them. I'll end here unless there are any other questions you could ask. Have a good night.